So this is an example of how to produce trace tables to see what's going on in a program as it runs. This is a form of white box or logical testing where we're checking that the logic of a program is correct, and you've got a range of examples to work through in the worksheet that I've provided. So we'll use Excel to create our trace table. On the left hand side of my table here, I'm just going to copy and paste the code from the exercises, so you can do this with whatever code you're wanting to trace. And on the right hand side, I'm going to track what happens to variables, and I'm also going to make a note of what happens when a comparison happens. So that's where the computer's deciding if something is equal to, greater than, less than, or true or false. And the first job is really to identify what the variables are in this program. So I can see I've got an X, a Y, and a Z at first glance. I don't need to worry that I've got them all straight away. I can add things later on, but they're the obvious ones that I can see. And also just looking down, I can also see there's a comparison happening at some point during the program where it's asking if X is bigger than 0. So I'm going to include that in my little list of things to watch for here. Now this kind of format that I'm using has a bit more detail than some of the textbook examples that you'll see, but I think it just makes a bit more sense and it's easier to track things through than some of those slightly more simplified examples. So now we're going to run the code and we're going to look at what happens to the variable at each line in the code. So I can see that in line 1 here it's setting X to 5, so I just record on that line that X has been set to 5. On the next line, Y is being set to 1, so on the same line, so that I can at any point look back and see where that thing happened, I'm going to set Y to 1, and the same for Z, I can see is being set to 0 here. Then we can see the program is asking a question. It's saying, is X bigger than 0? So I can decide if that's true or false. Well, X is currently 5. At any point in the program, I just look back up a column to the last entry and I can see what that variable is. So in this case it's 5. That's clearly true, so the while loop will run. So I'll make a note that it's true there. Then I look at what's changing. So X is going to be the same as X minus 1, so X is decremented to 4. Y is going to be incremented because it's adding 1 to Y, so that's going to become, look back, Y was 1, now it's 2. And Z is going to be X plus Y, and then all of that multiplied by 2. So X is 4, Y is 2, that's going to be 6, multiplied by 2, so the answer to Z is 12. Now, the program hasn't finished running because we've got this while loop here, so at the end of this this portion of the program, the flow control will be that the program will go back up and check that while condition again. Now an easy way of just representing that is copy and paste that section of code again, because that's what's happening next. So just paste it in here and then we can ask the same questions again. So we can say, is X bigger than 0? Yes it is, because it's currently 4, so that's still true. The while loop is going to run through. X is going to decrement, Y is going to increment, and then we've got 3 plus 3, which is 6 again, multiplied by 2. Then the same thing's going to happen again, so copy and paste that code again, because we haven't finished the while loop, we're still in it and checking. So again we say, is X bigger than 0? Yes it is. By now you can probably predict what's going to happen. So it's still 12, and then it all happens again. Now the value of this is that if I'm wondering why a program is returning a result at a certain point, I can look back at that point, look back to what's happening on that line of code and make any changes that I need to make. So if we just finish this off, X is still bigger than 0, X is 1, it's also handy for testing stop conditions, so we might find that this loop is going one time too many, and at this point we could pick up, it's because X hasn't been decremented at that point, and what we need to do is use a different programming structure to stop it. In this case it's doing what we expect it to, so that's not a problem. And then you can see by now that we're at our final point, because now we're going to ask, is x bigger than 0? And clearly it isn't. That now becomes false. And then we look back at the code and we can see, well, that's where the code ends, so there's nothing left to run. So that's a total run through the program until it halts. So hopefully that's been helpful in helping you to construct your own trace table so that you can see what's happening to variables in a program.